Good day everyone, this is John Mark Modular, and my topic is all about the applications of modular arithmetic under mathematical system. So in this video, you will learn the 4 applications of modular arithmetic. The first one is how to identify or verify an international standard book number or ISBN. Second is how to verify a universal product code or UPC. Third is how to validate a credit card number. And fourth is how to determine a day given a specific date. So, ISBN is essential as a product identifier used by publishers, booksellers, libraries, internet retailers, and other supply chain participants for ordering, listing, sales records, and stock control purposes. It also identifies the registrant as well as the specific title, edition, and format. ISBN also were 10 digits in length up to January 31, 2006, but since January 2007, they now consist of 13 digits. ISBN is composed of 5 elements. First is the prefix element, which currently can only be 978 or 979, and it's always 3 digits in length. Second is the registration group element, which identifies the country, the geographical region, or language are participating in the ISBN system. This may be 1 to 5 digits in length. Third is the registrant, which identifies the publisher or the imprint that is up to 7 digits in length. Fourth is the publication element, which identifies the action and format of a specific title. This may be up to 6 digits in length. Fifth and last elements of ISBN is the check digit, which is the final digits that validates the rest of the digits. Note that the section of each ISBN is separated by space and hyphens. Now for the 13 digits ISBN, also known as the ISBN-13, we will assign D sub 1 as the first digit, D sub 2 as the second digit, D sub 3 as the third, and until we reach D sub 13 as the final digit, or also known as the check digit. Then the check digit is chosen to satisfy this equation. Note that 3 are multiplied to digit whose subscript are even numbers. So we multiply 3 to D sub 2, D sub 4, D sub 6, D sub 8, D sub 10, and D sub 12, where each digit has a weight of only 1 or 3. Note that this quantity in modulo of 10, we're going to have a value from 0 to 9, and subtracting those values, we are going to have 1 to 10 as the final answer. Thus, if the value of D sub 13 or the check digit is 10, we are going to use 0 as a check digit. For our first example, let's try to determine the ISBN check digit of the book, the equation that couldn't be solved by Mario Livio. Its first 12 digits are 978-0-7432-5820. So 9 will be our D sub 1, 7 will be our D sub 2, up to 0, which is our D sub 12. All we have to do is to substitute those values to this quantity, where in the second, 4th, 6th, 8th, 10th, and the 12th digit will be multiplied to 3. D sub 1 will be 9, D sub 2 will be 7, D sub 3 is 8, D sub 4 is 0, D sub 5 is 7, D sub 6 is 4, D sub 7 is 3, D sub 8 is 2, D sub 9 is 5, D sub 10 is 8, D sub 11 is 2, and D sub 12 is 0. Then all we have to do is to get the sum of these quantities, which leads to 97. Since 97 modulo of 10, or when 97 is divided by 10, the remainder is 7. And 10 minus 7 is 3. Then D sub 13 is 3, or in other words, the check digit is 3. Next, we have the 4th edition of American Heritage Dictionary with ISBN 978-0-395-82517-4. Now, suppose that a bookstore clerk sends an order for the American Heritage Dictionary and inadvertently enters the number 978-0-395-28517-4, where the clerk transposed the 8 and 2 in the 5 numbers that identify the book. Note here that the current ISBN has 8 and 2 as the 8 and 9 digit respectively, not 2 and 8. Now, the receiving clerk calculates the check digit as follows. Using 9 as d sub 1, 7 as d sub 2, 8 as d sub 3, 2 as d sub 8, 8 as d sub 9, until 7 as d sub 12, we're going to have this quantity which is equal to 124. And since 124 modulo of 10, or when 124 is divided by 10, the remainder is 4, and 10 minus 4 is 6. Then the check digit or the 13th digit must be 6. Now, because the check digit is 6 and not 4 should be, the receiving clerk knows the incorrect ISBN has been sent. Consider that on this video we're only limited to the verification of ISBN. To verify 10 digit, we use to 10 to 1 as the width of the first to the 10th digit, and its sum and modulo of 11 must be equal to 0.
Back of the book, there is an ISBN. Let's write down my number here on the back. 01403181194. I'm going to take the first digit, multiply it by 10. The second digit there, I'm going to times by 9. The third digit, I multiply by 8. The next digit, I times by 7, and you can keep going. And the very last digit, you multiply by 1. Now what you do is you add these together. If you add these numbers together, you will get the number 121. And this number is a multiple of 11.
Universal Product Code, or the UPC, on the other hand, is a 12-digit number composed of 6-digit manufacturer identification, followed by the 5-digit item number and end with a check digit. Note that the UPC is one-dimensional barcode which scanners scan the code horizontally. This barcode is common in grocery items. Although you may encounter these two-dimensional barcodes and its special type is the QR code, we will not deal with those codes in this video. And similar with the ISBN, this quantity will be formed 0 to 9 since this is modulo of 10, and subtracting this quantity from 10, we are going to have 1 to 0 as the values of the check digit. And if the check digit is 10, we're going to make use of 0. In the first example, let's find the check digit of the DVD release of the film Alice in Wonderland, where the first 11 digits are 7, 8, 6, 9, 3, 6, 7, 9, 7, 9, 8. So 7 is our D sub 1, 8 will be our D sub 2 up until 8, which is our D sub 11. And substituting those values to this quantity, where in the first, 3rd, 5th, 7th, 9th, and 11th will be multiplied to 3 and getting this quantity, and we are going to have 155. And 155 modulo of 10, or when 155 is divided by 10, the remainder is 5. And 10 minus 5 is 5. So D sub 12 over the check digit is 5. Now for the second example, we are going to determine if the universal product code 70563244197 is valid, in which our 7 will be our D sub 1, 0 will be our D sub 2, and 5 will be our D sub 3, up until 4 will be our D sub 11, and 7 is our D sub 12. Again, consider that the first, 3rd, 5th, 7th, 9th, 11th digit will be multiplied to 3. And substituting these values to this equation, we are going to have quantity as equal to 93. And when 93 and modulo of 10 is divided by 10 and the remainder is 3, and since 10 minus 3 is 7, thus our check digit is D sub 12 has to be 7, which is apparently the one given here. Thus, we can say that this universal product code is valid. A credit card number is usually composed of 13 to 16 digits, where the first 1 to 4 digits are used to identify the card issuer. For MasterCard, the first 2 digits is any number from 51 to 55, while for the Visa card, the first digit is 4. And in this table, we can see the possible first digit and the number of digits in different credit cards. Now, to verify a credit card number, we are going to apply the LON algorithm, or also known as the modulo 10 algorithm. This algorithm is named after the name scientist Hans Peter Land. In the Land algorithm, the first step is starting from the next to last digit, second to be the last digit, reading from right to left or double every other digit. If a digit becomes a two-digit number after being doubted, treat the number as two individual digits. Second, get the sum of the digits. And third and last step is to check if the sum is equal to 0 in modulo 10.
First example, let's try to determine whether 5234 8213 3410 1298 is a valid credit card number. So beginning with the next to last digit leading from right to left, from this is 9, we need to double every other digit. So meaning 9, 1, 1, 3, 1, 8, 3, 5 will be multiplied to 2. So multiplying these digits to 2, we are going to have this 1. And if in case that a digit becomes a two-digit number after being multiplied to 2, just like 10 becomes 1 and 0, 8 becomes 16, and 9 becomes 18, treat the numbers as two individual digits. So meaning 10 treated as 1 and 0, 16 treated as 1 and 6, and 18 treated as 1 and 8. Note here that 10 becomes 1 plus 0, 16 became 1 plus 6, and 18 becomes 1 plus 8. And as we get the sum of these digits, which is 60, we have just to check whether that sum at modulo 10 is equal to 0. And since 60 modulo 10, or when 60 divided by 10, the remainder is 0, and it satisfies this condition, we can say that the credit card number is valid. In example number 2, let's try to determine this credit card number 52687912345678890 is valid. So beginning with the next to last digit leading from right to left. So we have 9, next we have 7, 5, 3, 1, 7, 6, and 5. Double the digits from right to left, starting with the second to the last digit. So we have 5 becomes 10, 6 becomes 12, 7 becomes 14, 1 becomes 2, 3 becomes 6, 5 becomes 10, 7 becomes 14, and 9 becomes 18. So after this, we come up 71, which is the sum of the individual digits. Since 71 modulo 10 or 71 divided by 10 and the remainder is 1, in which the credit card number must have 0 modulo 10, then this credit card number is invalid.